I dropped a whole 147-page contract document in.
The Applied AI Podcast, where tech meets ROI.
Mind blown.
Welcome to episode 9 of the Applied AI Podcast. I'm your host, Jacob Andra. Today I bring back Dr. Alexandra Pasi, machine learning scientist, CEO of Lucidity Sciences, and all-around extremely well-informed person on topics of artificial intelligence and machine learning. Welcome, Dr. Pasi. It's good to have you again.
Yeah, great to be back, Jacob.
Yeah, so we had such a good first podcast. I got so much great feedback from that. Everybody loved it. And, you and I, it seems like when we get our minds together, we just see things similarly, but we both come from such a different angle. I'm much more from the business application side. I'm not a machine learning scientist like yourself. And, you come from that deep research perspective. So it's great to, I think, bring the two minds together.
I agree. I mean, I think like the challenge of the era is forming that bridge, right? And that's actually one of the things I've been thinking about a lot when it comes to agentic AI. So I'm sure we'll talk about that a little bit.
Yeah, you're jumping right to it. Agentic AI is what we're going to talk about. So go right ahead.
Wow. Well, okay, yeah, let's jump right in. I mean, I think that the first place to start, kind of like we did last time, and where most conversations I have about AI start is like, what is AI? And I wrote about this recently. I've kind of given up on trying to like put some formal bounds around that concept because, I think we can talk a lot about the tools that are being deployed and we can talk a lot about the use cases. But one of the things that I've noticed is that when it comes to how people think about AI, and I think agentic AI is a great sub example of this, people tend to try to describe it in terms of a class of function or describe it in terms of a class of form and sort of like tools falling in under that. And if you try to like force it into a definition under either of those two paradigms, they don't really match up with each other, right? There's some overlap, but they don't really match up. And so I think that one of the things we do have in common, despite coming from very different backgrounds, is being very objective focused. And for me, that's the right approach to talk about AI through in general. And I think sort of the right way to understand agentic AI.
I absolutely agree. And I came into this wanting to sort of explore, to your point, that people kind of get these very fuzzy categories, these muddled categories. It might be enlightening to just go over some of the ways that the term is used, because it's used in so many very distinct ways and I think when people use it, they don't realize what they're actually doing. They think there's just this accepted definition of what agentic AI is, but there's not. And so to that, you can probably think of some ways. I can think of a few off the top of my head that people use the term. One is as a replacement for humans. So there's kind of now this new term in business context of digital employee. Like if you hire this AI and call it a digital employee, you don't need a human to do that specific role because this AI will do it. And very much agentic AI is used as a kind of synonymous term for that. And you've probably seen that a bit. And I think that's a misleading approach. I don't actually think any of the AI capabilities are able to do a human employee's job end to end and replace human expertise. And it's just a very muddled way of thinking about agentic AI from my perspective.
Yeah, I tend to agree with that. I mean, I think we talked a little bit about this last time. This idea that, maybe when it's a really strong labor market and everybody is hiring, you sort of create these really specialist niche roles. And on paper, they look like sets of tasks that should be easily automatable. But then as people try to become more streamlined and efficient, those tasks and the constellation of tasks that an employee is asked to perform become a lot more subtle and difficult for technology to automate. And so I think that the idea that you can replace a human sort of risk-free or, replace a human one-to-one is not going to be a very strong AI strategy for the vast majority of organizations.
Absolutely. I mean, obviously, we know that, for example, large language models, which are the class of AI that's getting the most usage and the most airtime in the press, certainly can be force multipliers so that one human can potentially do the job of multiple humans in the past, but it's not replacing anyone. So that's one common use of agentic AI. And here's another, is an AI that interfaces people such as customers. And so you often hear this in the context of customer service agent, outbound sales agent, making outbound calls. And you hear it used like, oh yeah, I need an AI agent for this, or a company is saying, yeah, we offer AI agents for that. And again, I think this is a misuse of the term agentic AI. It doesn't actually capture, it's not a particularly useful category, in my opinion. You've probably seen this as well.
Yeah, I think this is actually one of the most common starting places for a lot of people trying to, or at least it was. I do think it's falling out of vogue. But for a while there, as organizations were trying to figure out, like, what's our AI strategy, the go-to was chatbots. And I think, in a lot of ways, it was really just because it was kind of easiest to do that. I'm going to set up a little vanilla RAG system. It's going to have access to my knowledge base. It's going to talk to my customers. And that was pretty accessible. That was sort of the first, out of the box way that people were trying to use this, besides just like going straight to chat GPT. But I do think that, we've very quickly reached the limits of what those patterns can do. Like if you've already implemented it thinking that was going to totally revolutionize and transform your organization overnight, you're probably sitting there a little bit disappointed thinking like, okay, what's next?
Yeah, totally agree with that. And so then I have one more, which definition or way that the term is used that I think is, again, a sort of misunderstanding. And then I'll get to the one that I think is actually the correct definition or use of the term agentic AI or AI agents. And I'm curious to know your opinion on this as well. But one more common one I think that is misleading is the idea that an AI can go complete a task autonomously with no human involvement, and that capability constitutes agentic AI, like book me a flight to Fiji, or go do this market research, and I don't need to be involved. I just tell it what to do. It goes and does it, and then it comes back with a result. While that is certainly useful, and, in my opinion, results are mixed on how well these autonomous capabilities function. Some are better than others, and I think we're still in the early stages of that. AI able to autonomously complete some function is useful in a lot of business contexts, dangerous in others. There's a wide spectrum, but again, I don't think this is the most useful way of defining what agentic AI is. What are your thoughts on that?
Yeah, I agree. I think that, the definition is sort of subject to your own risk tolerance, which can change over time, change over organization, change over context. And I don't necessarily see as well that there has to be any AI component to a system performing something autonomously, right? That's done all the time. So it starts to get a little bit fuzzy. It's like, okay, well, I'll use an LLM and then I'll not pay attention to it. That seems like a kind of flimsy basis for a definition.
Absolutely, because long before LLMs hit the market, you had all of these integrations and triggers. You can use platforms such as Zapier to connect this up with that. If I get an email with this subject line, I want you to create a ripple. I want you to do this action, or send this alert, or whatever. You can wire up all kinds of workflows that have absolutely no LLM or AI involvement whatsoever, and you could, by this definition, call those agentic, right? But I agree with you that that's not the most useful way of defining it. So I have my pet definition of what is the most useful way of thinking about agentic AI. Before I say mine, I'd be curious to hear yours. Do you have one?
This is tough because I don't. I think that agentic AI is the kind of term where, it comes. A lot of terms in language don't have a meaning outside of their usage, right? That's kind of my philosophy of language. I'm certainly not the only one. And it's just one of those terms whose definition is so widely spread that I think for me, I choose to focus a little bit more on like, what are people trying to do when they talk about agentic AI? And a lot of times it just means like, I'm trying to accomplish a nuanced task with a lot of different moving components that have to feed into the evaluation. And some of those components are going to involve AI in some way. And I think that's probably the broadest I can get in the definition that sort of encompasses all of these things. Beyond that, I think it's, again, this kind of split between, do we describe it by its form? Do we describe it by its function? And I don't really have a strong personal opinion on one or the other being the right way.
Yeah. So that's a good point. I'll tell you my favorite definition and the one I think is the most functionally useful. And you tell me if you think it's more describing it based on form or function, or whether you think this is a particularly useful way or not. Feel free to totally disagree. But here's my favorite is um, an AI function that is able to complete a task, and that task could be very narrow in nature as part of some larger ensemble or capability.
That aligns pretty well with my intuition for the term on. I mean, I think that, you can have, um, in that sense, quite a lot of things qualified just through the broadness of the term AI. And I kind of think that's the right way to think of it. Like, I think there's a lot of people that tried to hold a stronger line for a while, like, no, only these things are agentic or only these things are AI. We talk a lot about AI transformation and the AI revolution. And I used to kind of roll my eyes at that because I think that a lot of things that were getting muddled were around AI as LLMs, right? And I didn't see the LLMs themselves as being like, necessarily the primary driver of this revolution.
Yeah, in the first episode when I had you on about a month ago, we went deep into the disambiguation of AI as much more than large language models. And that is such an important distinction. And I couldn't agree more with the importance of that. And so, yeah, another, I think, fundamental misstep when people talk about agentic AI is they're usually just referring to some large language model product, usually like a SaaS offering that somebody's created, and like, hey, it's agentic because it'll make calls for you, or it's agentic because it'll, book flights and you don't need to be involved, right? So that seems to be kind of heavily weighted in the conversation.
And I think that, what I've come to realize is that the AI revolution is really about people coming to see the role of technology as something different. And that's it. Like, it could be any technology, but it's about, I used to think of technology as like I need to communicate. I'm going to go communicate through this technology. And that's like the role of technology. And now technology becomes much more integrated in our organizations to the extent that, it becomes part of the information flow, part of the model of our businesses and our worlds in a way that can't really be extricated so cleanly as like, this is the one functionality. And so I've become a lot more empathetic to people describing this, general broad AI revolution through the understanding that it's about changing the way we understand technology's role within the things that we do. And because the LLMs were so really, I think, captured the public's imagination on that front and opened people's eyes to like, what could we do? They've been sort of the symbol for this new way of thinking, but I don't think it's anything restricted to, an out of the box LLM.
Absolutely. That's such a great point. And, over the last several decades or, many decades, the US has transitioned and much of the developed world has transitioned to a largely knowledge-based economy. And so I like what you said about the technologies themselves are being so inextricably woven with the knowledge that they're mediating that it's hard to even separate the technology from the product. And there is that, kind of deep interweaving of the two. So that's a really cool perspective. One of the things, go ahead.
I was just going to add on to that and say that I think that when it comes to agentic AI, what the zeitgeist of the word agent points to is that sort of sprawling integration, right, of all of these different components that changes the way we interact with technology and the knowledge that it helps, that it sort of serves as the logistic network for it.
Yeah, no, that's a great point. To circle back to what you were saying a moment ago about large language models, it's really weird because I'm going on a lot of, panels these days and talking to a lot of people. It's like I'm giving two messages that almost are the guardrails for how I think about large language models. On the one hand, like, let's look at how amazing they are. Like, how awesome is it that an average person now can interact with a powerful technology in this way with natural language? Before, you had to be a programmer, a scientist, machine learning expert to even interact with these capabilities. So how amazing is it that everyday people, to your point a minute ago, can have direct access to interact with some form of artificial intelligence, even if it's one small sliver of the AI universe, they're still able to interact with it With layering now, we're going to get to that in a minute because we're going to talk about neurosymbolic, which I'm excited. But with layering, you can even have natural language interacting with deeper layers of AI, not just the LLM, but with the LLM being a translating layer to get you to deeper layers, right? So that's so cool. And I don't want to downplay that. I don't want to minimize how awesome that is. And LLMs are incredibly capable of a lot of things. So I feel like on one hand, I'm almost hyping how awesome LLMs are. But on the other hand, I'm documenting through all of the ways I'm using them in real world scenarios how absolutely weak they are at so many things. And so it's like both messages at the same time. I almost feel like I'm schizophrenic because I'm saying how amazing they are and how absolutely terrible they are at so many things, especially once you start getting to large contexts. I mean, they just absolutely fail right and left in a lot of different ways. And I'm documenting the specific ways, structural, logical ways that I'm planning on publishing about this. So almost a detractor type of paper, but really I'm trying to showcase that this stuff is nuanced. It's not one or the other. You have to have some nuance and you have to have some understanding about what they're actually good at and what they're not.
I very much live in that world too. And I think it's in many ways a kind of lonely world to live in, but it's the one that I see more and more people gravitating to because it's like the more you get exposure to these things and the more you understand how they work, the more that's just the inevitable position. And I think that a lot of that gap between sort of, how incredible they are and how limited they are is actually the gap of language. And I talk about this a lot when it comes to LLMs, which is that there's really kind of like two gates that must be passed through for an LLM to be capable of a thing, right? And the first gate, I won't even get to the second gate because the second gate is about like math and the math that drives the LLMs. Setting that aside,
Maybe you can get to it at a high level. I'm curious.
But I think that the primary gate is so powerful of a limitation that it's just like the only one that needs to be paid attention to large extent, which is the gate of language, right? Language is incredibly powerful. It embeds implicitly so much meaning, at least subjectively felt meaning into it, that it's easy to kind of like not think about what it is. But when you actually really start to get down into doing these nitty gritty little tasks, especially really quantitatively nuanced tasks with a lot of numbers, tasks with a lot of details, that's not really what the syntax of our language is designed to do, right? Like our language was designed or evolved to be able to accommodate like between large hunting parties, for instance. It's not really something that's intended to optimize along, 200 different components of a large manufacturing or logistics network down to like a very high level of precision. That's just not at all what kind of created language. And I think that LLMs are incredible from a user point of view because they allow us to bridge into, deeper technology through a format that we're very familiar with. We see the world through language. We interact with each other through language. It feels very natural. It feels very human. That's a double-edged sword for as powerful as it is, right? Because we often don't have to process the nuance or process the detail of what we're trying to do when we enter into it with a natural language prompt. So I actually got an email ad campaign from ChatGPT recently that opened that way. It was like, you don't have to have a question. Just start. And like, that's true. I actually think that's a big part of the value prop of LLMs. I also think that's where a lot of the danger comes from because it can coax us into thinking we've kind of thought through a problem in all of its nuance when we haven't. And so one of the benefits of coding something up is that like you really had to get specific to tell the computer explicitly what to do. So I think that's exactly where both the power and the danger come in, is that now we're developing these systems to try to bridge that gap. And it's a very, very delicate gap to bridge.
Yeah, that's a great point. And I like how you bring that almost evolutionary anthropological lens to human language and the way humans communicate. Because you're right, we have nothing. I mean, modern society is the tiniest blip on the evolutionary time scale. And so we have nothing, no precedent for a large manufacturing organization, to say nothing for a 8,000 dimensional vector embedding model, something like that, right? It's just beyond our ability to even wrap our minds around practically.
Exactly. I mean, it's the reason that we develop like Gantt charts and OKRs and stuff like that. Like, can you imagine if you had to run an organization without using a spreadsheet, right? Just by talking about all of the things that were happening in it, it would be just mind-bogglingly inefficient and overwhelming.
Absolutely. Let's transition into neurosymbolic AI. I have a feeling that this is going to be a growing trend. It's one that I'm leaning heavily into. It's one that my company, Talbot West, is exploring actively. I want to hear your definition of it, but it seems to me that part of what's going to be driving the wave of neurosymbolic AI is precisely the shortcomings of large language models, the ways in which they just are inadequate to many types of tasks we need them to do, we wish they could do, and they can't do. And the neurosymbolic route is sort of a way of almost propping up or compensating or helping extend or augment their capabilities, is what it seems to me. I'd love to hear your perspective, and then how you would almost like define the term neurosymbolic AI.
I'm a big fan of neurosymbolic methods. I've been a big fan of neurosymbolic methods from the beginning. I think a lot of people don't realize, but some of the early advances that LLMs made in, like, the math Olympiad problems and being able to like do math and prove math, came from these neurosymbolic methods. In particular, they were combining LLMs with a language called Lean. And just to describe sort of at a very high level what the symbolic part of neurosymbolic is. So neuro is, neural networks. So using some of those frameworks, neural networks are at the basis of LLMs themselves, of deep learning. If you hear that, it's just like, a bunch of neural networks kind of working in concert together, so to speak. The symbolic component is very structurally different. So the neural component is probabilistic, right? That's more in the spirit of the sort of like traditional statistical machine learning. The symbolic part is more in the spirit of like math or computer programming. So most people don't deal a lot with symbolic systems. Most of the work that we do is a little bit more probabilistic. Most of the thinking that we do is often kind of probabilistic. We're thinking of things that might happen based on things we've seen happen. Symbolic reasoning is about deductive reasoning using a set of symbolic rules. So you're leaning into the syntax of the thing, right? You've got a bunch of symbols that are allowed. You've got the rules by which those symbols can be manipulated. And then you have this automated way to look at a set of symbols and say whether its deduction from prior sets of symbols were valid. So you can go through this, chain of reasoning that's so tight that you don't have to make reference to the external world. You can just look at the symbols and the rules for how those symbols can be manipulated in order to see whether that was a valid, move or deduction. And the neurosymbolic systems combine both of these methods, right? So you get the advantage of these more probabilistic methods that allow you to make these kind of like big inferential leaps. But then you get the rigor and the validity that comes from having the symbolic component to sort of check that each of those steps was made in a way that is consistent with logic, really.
Yeah, that's a great way of explaining it. And I don't have your formal academic background and probably the rigorous type of language you bring to bear to describe it. But one way that I like to think of it is that the neural networks can be just very loose in terms of the being tethered to reality, right? They're very associative, and that's actually part of their power, but it's also part of their downfall. It's where hallucinations come from. So they're very associative, and symbolic systems are very like rigid and tethered. And so it's kind of the combination of the two that you get best of both worlds and the strengths of both. Would you say that's fairly accurate?
That's exactly right. And so I think that on paper, it's kind of the perfect solution. The challenge of neurosymbolic systems, I mean, there's a couple. One is that it can be fairly computationally intensive, depending on how it's done and sort of the scope of the project. That tends to be less of the barrier. Often the barrier for implementing this in a lot of contexts is just that it is very difficult to symbolically formalize a system. So mathematicians did it at the turn of the century, right? And that took a lot of work, and math is a quite rigorous and defined field already. Trying to put that kind of rigor and structure around the domains that businesses would be interested in is doable. It just takes more work than I think, you would expect to put in trying to just use an LLM off the shelf.
Absolutely. And there are so many applications for a good neurosymbolic system. I mean, we could extrapolate many. I want to get to one specific use case that's very core to what Talbot West does, but I mean, you could think of many, like for example, pharmaceutical research. The symbolic system could be anchored in all of the known chemical interactions, all of the known compounds, the formal logic behind the drug discovery process and all of this. And then the neural could be like very loose and associative. And that's what's going to find you new combinations that you've never thought of before. That's what's going to extrapolate out and do a lot of inference and say, come up with revolutionary ideas that can then be tested, etc. Right? But if it's not anchored in some underlying kind of symbolic structure to keep it tethered to reality, those associations are going to be far less useful. They could be just extremely fanciful and not at all really applicable. And so you can think of across like almost any industry, a very high functioning neurosymbolic system would be incredibly valuable.
Yeah, and I think that, what you're describing is really kind of a generalization of what a lot of people might describe as neurosymbolic systems. So I think that, one of sort of like the most canonical examples of a neurosymbolic system is the one I described that was used to solve math Olympiad problems. I'm going to like make a leap of reasoning, and then I'm going to use this paradigm of lean to check that that was correct. And if I'm using that paradigm, I know for a fact that what I end up with is valid, because that's the power of lean in this formalization. The other way that you describe doing things, which it actually can be applied much more broadly, doesn't come with that total guarantee of validity, but it still structures and constrains the problems that for most business applications, you're still going to come up with an answer that's, usable and reliable. And so I think that in that paradigm, and I love this version, because this version is one, it's very flexible. You can use a lot of different technologies. It doesn't even have to technically be a neural net. So you don't have to have that neural component for the pattern to hold. But two, it really capitalizes on the domain expertise of the organization, right? And in a lot of cases, that's that organization's differentiation. That's your moat. You've been putting decades into gaining this knowledge. And so this provides an opportunity for you to codify that in a way that AI and machine learning can capitalize on. So drug discovery is a great example, right? You can use that chemical knowledge to decide what components are relevant to then put into a machine learning model, so that as it's forecasting out, it's going to be doing that on the basis of things that are more relevant. That's the case for, if you're trying to like forecast revenue, you want to be putting in the things that are relevant for your revenue, right? I want to be putting in different components of marketing spend. I want, some numbers related to different kinds of sales activity in the regions that it's happening in. I don't want to then put in a bunch of additional superfluous information that's not relevant, because that's going to sort of increase the amount of noise that the model that I'm trying to train probabilistically has to try to find its patterns around.
Yeah, that's great. My business partner, Steve Carfiot, came up with what I thought was a cool analogy for neurosymbolic, which is if you picture like the early single-celled organisms that evolved in the oceans, these are just like squishy little organisms, single-celled. But then, there are even squishy multicellular organisms in the ocean, such as octopi, jellyfish, etc. But on land, where gravity applies, a squishy organism doesn't fare as well. You start needing a skeleton. You start needing some structure to hold it up. If we were just blobs, we wouldn't do that well. And so you could almost liken the symbolic aspect to the skeleton that gives it a form, a structure, and then I guess everything else would be the neural network in that analogy.
I think that if that's the pattern we're going to be thinking about, which is actually probably the right pattern for most business problems, I even venture to say, or a significant chunk of them, then you're actually more in the realm of machine learning, where that neural component doesn't have to be an LLM, and it doesn't even have to technically be a neural network type of technology. It can be any machine learning algorithm that you put in there. These sort of symbolic elements are found in your world model of what the relevant pieces of information are to that outcome. So to bring in like one other set of technical tools that you might think about using within this context is, if I'm going to be creating, say, like a predictive model, or even a model that like automates a label. So like a diagnostic model, right? I want to diagnose a certain condition. What I need to know, and I'll use the diagnosis example just because we've already talked a lot about prediction. What I need to know is, what are the inputs that go into making that diagnosis? What I don't need to know, and what the probabilistic machine learning algorithm is intended to do, is to find the way that those inputs combine to generate the diagnosis. And so one tool that you can use to try to understand what are the inputs, what generates a certain disease state. You can use something called a DAG, a directed acyclic graph, which just lets you kind of draw out what are the causal connections in this problem, right? So like what goes into this certain type of heart condition developing, and then I can put that in to the input space. Or what are sort of the signs, the telltale signs of this disease from a biological perspective. I can put that into the input space, and then the machine kind of learns the patterns between these things to produce the diagnosis based on the historical data. So that is a pattern that doesn't require necessarily an LLM. And if that's the route you want to take, it's a really good way for businesses to, one, be able to train their own custom models from the ground up in a very kind of accessible way, and two, really utilize their own differentiated knowledge and produce a little bit of a moat around that model and that product.
That's great. I love that, because one of the things Talbot West is really big on is helping organizations through standardizing their tribal accumulated knowledge and then making that accessible and queryable. And to date, we've mostly done that through RAG type of setups. But as you know, that's large language model based. And if you get a large enough body of knowledge, it starts to get a little bit squishy. And it's not, the most reliable in terms of retrieval. Plus, you can't extend it in some of the interesting ways that the architecture you're proposing would allow you to do. So I like that.
Well, and I think, even just if we want to stick in RAG, there's also ways that these worldviews can help a RAG system perform much better. So, when you think about like vanilla RAG, you have this very large knowledge base and you're maybe like chunking it up into kind of arbitrary blocks to make, and then when a user queries it, so I'll put in like a little user query, and then it'll vectorize that and it'll just go check against all the blocks and pull the things that it thinks is the most relevant based on how similar those vectors are. With a more nuanced approach to RAG, I might actually have a picture of what kind of information is going to be relevant for a certain type of query. And what I can do, and might describe that through like an ontology, right? So you hear ontology-driven RAG discussed a lot. And what that could basically accomplish then is I have a user query, and there are cues within that query that indicate sort of like where within that picture of knowledge or information or functionality is that user query living. And I can tag my data according to those different attributes. And so when I go to search, I can actually be running that search off of those different attributes that bakes that institutional knowledge or that domain knowledge on top, and creates a much more powerful RAG system, even across a very large knowledge base.
Yeah, it sounds like that's almost even a prototypical neurosymbolic setup, because you are anchoring the squishiness of the large language model to something. It sounds in this instance, it's a sort of an indexing function you're describing.
Yeah, it's funny. I hadn't thought of like ontology, like sort of a graph-driven RAG as being a neurosymbolic system, but I think there's total argument that it is. You do have these, sort of more rigid symbolic worldviews, and then you have the retrieval function, and sort of, the generative function of the LLM. So I like that. I mean, I'm all for kind of expanding the use of these terminologies to the extent that it really helps to capture patterns that enable function.
Yeah. Let me describe two use cases Talbot West is currently working on, and that I think, we are actively pursuing some neurosymbolic approaches, and I'd love to hear your perspective on these, if you're game.
Absolutely.
Okay. And these are actually very related. So I'll just rattle both of them off, and because they're so interconnected with each other, and you can then weigh in. So the first is with our clients, we have to, a lot of times we do an evaluative process. So we're not just going in guns blazing, let's deploy AI in your organization. Like there are so many intricate dependencies, just like I love that you used that example early on of, we're not equipped to deal with the complexity of a very large manufacturing organization. And so our first task is to get a handle on the complexity, all the dependencies and adjacencies and the direction these dependencies flow. And it's like a tangled mess of spaghetti where everything depends on everything else. And, usually they've grown in this organic manner, not a lot of like forethought or foresight. And so it's so much just to even be able to, in any kind of intelligent way, recommend next steps. I mean, there's so much to get a handle on. And so We do use large language models a bit, obviously being careful with not sharing private data and all that. But so we're using large language models a little bit to help us in this process. But again, we're running into some of these limitations, which they're just so squishy. They can't handle that much context. Because when you're talking to a mid-sized organization with this level of complexity, the body of context just gets astronomical. There's no way a large language model can even hold that all in context. It starts forgetting facts. It starts getting squishy, even if it has access to a lot of context. It can't remember what depends on what, right? And so it's a lot of human cognitive load to do this process. And we would love a neurosymbolic architecture that helps anchor in all of the known facts about the business. And as those become more and more established, sort of becomes this bedrock, if you will, that populates with the known facts, relationships, dependencies, and the directions those flow. So there's no squishiness about those. And then, with sort of an indexing or tagging system, as you need a large language model to help, let's now map this specific subtopic of how the new ERP data sources flow, right? Or, where they need to flow from and how ready they are. And so in this body of knowledge, we probably have a lot of information about that, but it needs to be traced back through all of these kind of precursor conversations, et cetera, right? So you get the idea there. There's just a lot to map. You can take any one thread and follow it, and you want to be able to have that firmly anchored in known facts and not just get like all squishy with it. So that's the first use case. Second one is we're building a platform called Biz Foresight that essentially helps business owners know how to value their company and get it ready for sale. And it is AI powered. There's an AI chatbot that's what the customer interfaces with, but it's also ingesting both in the form of like document uploads and conversations with the business owner. It's ingesting a lot of facts and information about the business and populating these machine learning models so that it can then better inform the business owner and guide and direct them. And it's based on a very defined methodology. So we have this very robust methodology. It's about how to translate that into the right machine learning. And so this is a neurosymbolic system because, again, just like my first example, under the surface, these business facts about this particular owner's business need to be very anchored, validated, verified. The large language model needs to be referencing the known facts, and it needs to be building out a profile of the business. It can't get squishy with the facts or the logic or with the methodology that it's all based on. So you can see how those two are related. There are a lot of other cases we're looking at for neurosymbolic systems, but these are kind of two of the front burner ones we're looking at. So I'd love to hear your thoughts on those and how you might approach either one of them or both.
Yeah, I think that these kind of high level questions of business strategy or operations are a really good example of a place where you can take, you can sort of templatize a lot of these questions. If you have a good picture of how a business works, especially if it's in a particular industry, and then you've got like a bunch of different configurations that can be gotten, then you can go, to a large collection of unstructured data or conversations with the business owner and try to kind of like parse these things through in a way that makes sense to sort of populate this underlying model of what a business looks like, how a business operates, and then in particular, configuring it in the right way, how this business operates. So I think that that's a good example of such an application. I am always a big fan of, if you're thinking about how do I understand my business in this symbolic way, if you are doing solid financial modeling to the point that you can do financial scenario planning, you're already thinking about your business in this way, right? And so then it's a matter of how do I take that knowledge and sort of structure it in order to, use this in combination with some of these more probabilistic tools to try to understand my business better, or use that as the interface rather than, me going and running a bunch of different scenarios through my spreadsheet. I mean, it's funny. I think that people probably don't realize how much they're already doing the kind of activities that would allow them to architect out an agent for their use case. And I do think that in a lot of ways, it's easier for organizations to build their own agents, right? And you can if you have a robust framework, then you can really configure that to the customer. So I think that's still a possibility. But it takes more work to abstract something out to apply to multiple businesses than it might to try to create a system for your own. And so I think that when businesses are thinking about how to agentic AI, I think that off-the-shelf tools may not always be the best place to start. They may seem kind of, easy to access, but getting in there, getting your hands dirty, and what's this business actually doing? How is this business pieced together? I think that if you do that difficult work up front, you may find that actually building, an agentic system or building out some AI tooling that's going to help you answer these questions is going to be much and lighter of a lift than it seems. But if you go in without having done any of that heavy lifting, without trying to understand your business, without really abstracting to the perspective or formalizing to the perspective where you can introduce these tools, and you're just like, we're just going to do AI in a bunch of places until something works, like you can burn through a lot of money with no ROI that way.
Absolutely. And it's something we see all the time. And look, I don't want to poo-poo off-the-shelf tools because oftentimes you can find a fit where they solve an immediate pain point. But I look at those as more of a shallow implementation. They're not usually integrated into the very kind of heart of the business. It's more like deployed on a surface level, solving an immediate pain point, creating some efficiency. And great, if you find the right one that's getting you some ROI, that's perfect. But we're usually looking like, how do you integrate much more into the actual workings of the business, much more customized? There are all kinds of trade-offs, of course. If you deploy a custom solution, then it has to be hosted and maintained, and there are all those costs. But to your point, if it's very dialed in to the business and it's actually integrated with what they really need, much more than an off-the-shelf solution could be, then the ROI is probably going to be there, and it's going to be well worth the additional cost and expense. But all that has to be evaluated. It's a non-trivial problem to even do the evaluative process and be able to intelligently recommend what's going to be best for a given company.
That's kind of the chicken or the egg problem, right? So if you know your business well enough to quantify the ROI of a given AI initiative, it's probably going to be a successful initiative. If you don't know your business well enough to do that evaluation, you're probably not going to have a shot at making it impactful. And so I think that that's one of the difficulties, right? Is that even being able to model the ROI of one of these spanning, AI initiatives is itself kind of an indication of the likely success of that initiative in the first place.
That's a brilliant point, and I think that's a great one to end on. Thanks so much for coming on the podcast again. This has been a great conversation.
Yeah, absolutely. Thanks for inviting me back.